Good morning, friends. Today we are going to discuss about the chapter 11, dual nature of radiation and matter. Already we discussed about the ray optics and wave optics. In ray optics we discussed about the reflection and refraction of a light. Actually there is due to these two phenomena explain the particle nature of a light. That represents the particle nature of a light. And in wave optics, we discuss about the interference and diffraction. These two phenomena represents the wave nature of a light. In this chapter, first we discuss how we obtain the electron or the emission of electron take place from the metal. And we also discuss about that the photoelectric current and what is the energy of these emitted photoelectrons. About that, we also discuss about the Einstein's explanation about the photoelectric emission. What are the kinetic energy of this photoelectron? And last, we discuss about the uncertainty principle of Heisenberg. So there is the content of this chapter. Only for 5 marks. Question asked in board exam from this chapter. This chapter is very easy. The main thing is the photoelectric emission. And what are the emitted photoelectron, numbers of the photoelectron emitted from the metal is depends on what? Or which parameter of incident light. And what are the kinetic energy of this emitted photoelectron depends on which parameter of photoelectrons. We also discuss with help of a graph and then we discuss its characteristics in this chapter. Clear it? At present we are using the solar panel. While in solar panel the electric current is formed. Already we discussed in chapter 3 electric current. The flow of electron forms the electric current. So here, yes, the light is incident on a metallic surface, electrons are emitted, and this emitted electron passing through the circuit, it forms the electric current. Clear this? Okay. Now, in dual nature of radiation and matter, we start our discussion from explain the emission of electron and from metal and discuss the different method to obtain the emission of electron from the metallic surface or the surface of a metal. Before starting our discussion about the emission of electron, first we understood about that in a metal. There is the metal. Metal is made up of the two types of the ion, positive and negative. Positive ions are fixed at their lattice point and forms the geometric pattern. While the electrons are free to move within this metal. Electrons are free to move within this metal. Therefore, the electron perform the zigzag path. The path of an electron is not a stationary. Already we discussed in chapter 3. And also we know in chemistry, any metal or any object is made up of the numbers of the atoms. In atoms, the small central region that is known as the nucleus. In nucleus, the positive ions are present, while the electrons are revolved in a circular orbit around the nucleus. And these electrons are bound with these positive ions because force of attraction exerted between the nucleus and these electrons. While what are the electrons in outermost orbit are bound by the less attractive force, therefore it is possibility to remove this electron first. Okay. So keep in mind this concept also. Now there is the metal. We are using the metal at room temperature, that means the approximate 27 to 30 degrees centigrade. Already we discussed in 11th standard, these positive ions or the particles of a metal or the material But this is the kinetic energy, half m square is equal to 3 by 2 kb into T. So kinetic energy of the molecule is directly proportional to the absolute temperature. As the temperature increases, so its kinetic energy is increases. Here, the electrons are free to move within the metal. Therefore, its kinetic energy is also depends on the temperature. Okay. Now, positive ions are fixed at their latest point, but they are oscillate about their mean position according to the temperature of a metal, either horizontally or vertically or any direction about its mean position. Clear this? Okay. Electrons are free to move this conductor, but itself not escape from this surface of a metal. Not escape from the surface of this metal. Okay. So when this electron gains some energy, at that time the electron can escape from the metal. Clear it? Okay. For that purpose, normally the electron cannot escape from the metal. Clear? So in whatever condition they can escape. Here the electrons are moving in the space between the two positive ions. Therefore, the force of attraction is also take place or acting on this moving electron by the oscillating positive ions. Oscillating positive ions. When the temperature of this metallic surface is increases, therefore the kinetic energy of oscillating positive ions also increases and kinetic energy of the electron also increases. When the electron gets sufficient energy, at that time the electron can escape from the metal. Electron can escape from the metallic surface. And this emitted electron is known as the emission or the emitted electron, and this process is known as the emission of electron. Clear this? So before starting our chapter, we keep in mind that there is the concept of the metal and what is the formation of the atoms. Here the electron, that means the negative ion and positive ions, here bounded by the force of attraction. When the electron gets the sufficient energy, or this energy is more than the binding energy, at that time the electron can escape from this force of attraction and it becomes the prey. And when this electron gets the much more energy, at that time it can also escape from the metal. And this electron is behave as an emitted electron. Emitted electron. Clear this? Okay. Now, in this side, our first question is that explain the emission of electron from the metal and discuss the different methods of to obtain the emission of electron. So according to our discussion, normally the electron cannot escape from the metal itself. Okay. When the temperature of the metal increases, so what's happened? The kinetic energy due to oscillation increases, and when this energy is more than the binding energy, so electron will escape from the surface of the metal. Okay. Now, but due to the attractive force between the positive ions and negative ions, electron again attack to the metal surface. Here just we discussed about that between the positive ions and electron has the force of attraction. So due to the temperature increases, oscillation increases, kinetic energy increases. Now here the kinetic energy of the electron is much more than the binding energy. At that time the electrons are free, but that is bound again by the metallic positive ions. And if the energy of the electron is more than the energy due to the attractive force, then only it can escape from the metal of the surface. And when the energy of the electron is much more than the energy due to the attractive force, at that time the electron can escape from the metal. Now the different method of emission of electron. Here are the three different methods. One is the thermionic emission, second is field emission, and third is photoelectric emission. Now first we discuss the thermionic emission. So when the current is passed through a filament of metals are heated, electron gain the sufficient heat energy or the thermal energy, and electron escape from a metal. Such emission is known as the thermionic emission. So this type of the emission is take place in picture tube. Before the 5 or 10 years ago, at present we have no LCD or the LED TV. At that time we have the LED TV with the TV tube. As we switch on, it takes the 1 or 2 minutes to display the picture. So due to that reason, when the current passing through the filament, so as a result what's happened, the filament is heated, and as a result the metal is heated. So what are the electrons and positive ions on the surface of the metal? Get kinetic energy of these ions increases, and as a result the electrons start to emit from the metallic surface. And this electron incident on the TV screen and produce the picture. Clear this? Okay. Now, so what is the thermionic emission? For that purpose here, in picture tube, so here there is the metallic surface, and here there is the filament. Is the current passing through this filament? So what's happened? So this filament is heated. As a result, the metallic plate that is known as the cathode is heated. So this cathode or the plate is made up of the conducting material. So positive and negative ions are present. As the temperature of this metallic plate is increases, so the kinetic energy of the electron also increases. As a result, the electrons are emitted from the metallic surface and incident on a screen. There is our emitter, anode. There is our anode. So what are the electrons are emitted by the metallic plate or the cathode are collected by the anode, and as a result the current is passing to the plate, passing to the surface. So this phenomena is known as the thermionic emission. Right? Here the electron is emitted due to the current passing to the filament or hitting the plate or the conducting material. And due to that result, what are the electrons are emitted? That is known as the thermionic electron, and this process is known as thermionic emission. Now, example of thermionic emission is from diode, and TV tube. The electrons are emitted by the thermionic emission. Next is the field emission. When the electric field of 10:8 volt per meter applied to the metal, the electrons are pulled from the metal. Due to high electric field, such emission is known as the field emission. The second method is that as we apply the very high electric field across the metallic surface. So what's happened? So due to the very high electric field, the electrons are pulled from the metal. Clear? Okay. Just visual this diagram of field emission. Now there is the metal. As we apply the very high voltage, here the positive terminal, here the negative is connected at the end. Here the electric field E is equal to 10:8 volt per meter. So this terminal is positive, there is negative. According to our discussion, here the positive ions are fixed at their lattice point. Some electrons are free at room temperature and some are bound with these positive ions. Right? Some electrons are free to move within this metal. And some electrons are bound by these positive ions. Already we discussed this in atoms. Nucleus is positive charge. Electrons are revolve in circular orbit around the nucleus. So some electrons are bound with the nucleus and outermost orbit the electron are free. So as we apply the high electric field across the metal, so what's happened? Due to this positive terminal, the most of the electrons are hit by this positive terminal. And what are the electrons are bound with the positive ions in the nucleus are also pulled down from this. Because the high electric field, as a result, the electrons are attracted with the very high force. Therefore, the electrons are pulled from this covalent bonds. And as a result, the electron, flow of the electron takes place in the circuit. So this phenomena is known as the field emission. It's known as the field emission. And now next is the photoelectric emission. That is the most important point of this chapter. Because in this chapter we are discussing about the photoelectric emission. Okay. When a radiation of proper frequency incident on a clean metallic surface of metal surface, electrons are emitted from it, and such emission is known as the photoelectric emission. For that purpose, we do the diagram like this way. There is the metallic plate. As the light with the sufficient frequency is incident on this metallic plate, what's happened? We know that light is the bunch of energy. Actually, the light is made up of the numbers of the photon having the frequency there. So the energy of this photon E is equal to hf. There is the energy of one photon. Here the numbers of the photon are present in this bunch of light. Therefore, total energy is equal to NHF. NHF. We incident the energy. We incident the light. That means the energy is incident on a metallic surface. Therefore, what are the electrons on this metal gains the energy. And when the energy of this electron is more than its binding energy, so this electron starts to emit from this metal. And this phenomena is known as the photoelectric emission. Again, what is the photoelectric emission? When the radiation of proper frequency incident on clean surface of metal. So electron gains the energy, and when the energy of the electron is more than the binding energy, so electrons are emitted from metal, and such emission of electron is known as photoelectric emission. Is known as photoelectric emission. And these emitted electrons are known as photoelectrons. Clear this? So how the emission of the electron takes place from the metal? In the beginning we discussed about that the electron cannot escape from the metal itself. When it gains the energy, sufficient energy, this energy is much more than the binding energy, so electron can escape from the metal. Here are three different methods for emission of electron. One is thermionic, second is field, third is photoelectric. In thermionic emission, the filament is heated, that means the metal is heated, so electron get the energy from the temperature, or it gains the thermal energy due to the increase in temperature. And emission of the electron take place, and this emission of electron is known as the thermionic emission. Second is the field emission. When the very high electric field is applied across the metal, so what's happened? The electrons are pulled from the metal. So that is known as the field emission. And third is photoelectric emission, when the light of proper frequency is incident on a metal, so electron gains the sufficient energy and itself emitted from the metal. And what are the electrons are emitted due to the incident of the light? These are known as the photoelectrons. Clear this? So that is the basic concept of this chapter, beginning of this chapter. Clear? Okay. Just we discuss about the different method to obtain the emission of electron. Right? Okay. Last method is that the photoelectric effect. When the radiation of the sufficient high frequency incident on a clean metal surface. So what's happened? The electrons are emitted from the metal. Electrons are emitted from the metal. There is a metallic plate, circular plate. When the sunlight is incident on this metal. So what's happened? The electrons are already present on this metallic surface. Some electrons are bound with the nucleus, and some are free. When this electron gains the sufficient energy, then the binding energy, so these electrons are emitted from the metal. That is a photoelectric effect. Clear? Okay. So electron itself not emitted from the metal. So we have to do the some work to emit the electron from the metal. According to the work energy theory, the work done is equal to the change in kinetic energy of the electron. So that is the work energy theory. Here we supply the energy in form of a incident radiation of proper frequency. Because we discussed just that whatever the light is incident, light is the bunch of photon. The photon has the frequencies F, therefore HF is the energy of photon. Energy of photon. We also discussed about this in this chapter. After the Lenard's experiment, we will also discuss this thing. So HF is the energy of one photon. That means this light, here the numbers of the photon are incident on metallic surface with the energy HF. Therefore, the energy is given to the metallic surface. And this metallic surface, whatever the energy gained, this energy is gained by the electron. When the energy of the electron is much more than the binding energy, so electrons are emitted. Therefore, our aim is, what is the work function? Work function is that the minimum energy required to make the electron free from the metallic surface. This minimum energy is known as the work function. This minimum energy is known as work function. Here the total energy incident on metallic surface En is equal to NHF. Out of this NHF energy, the electron gain only the required energy, and then electrons are emitted from the surface of the metal. So with whatever the minimum energy required to electron to make free from the metallic surface is known as the work function. Here the definition of the work function is this. The minimum energy required to make an electron escape from the metal surface is known as the work function. Work function is denoted by this symbol phi. SI unit is electron volt. That is the unit of energy. Already we learned about the two additional unit in chapter 2 in 11th standard. Atomic mass unit and also the electron volt. These two units are the energy, are the unit of mass and energy in atomic and nuclear physics. Atomic and nuclear physics, we are dealing with the electrons, proton, neutron are very, very small. Therefore, its mass are also very small. Therefore, the mass of the electron is not reliable to explain, to mention in kilogram or the gram. Therefore, the mass of the particles or the atoms is measured in atomic mass unit and energy is in electron volt. Therefore, the SI unit of the work function is electron volt. Already we are familiar with this electron volt energy, this unit, because frequently we are using 11 standard and also we are using 12 standard. Work function of a metal depends on types of metal and surface of a metal. Okay. Again, the question is that define work function and right, it's a SI unit and work function of a metal is depends on which factor. First, the definition of the work function is that to define the work function, keep in mind the photoelectric effect. Light is incident on a metallic plate. When the electron gets the sufficient energy, so electron gets emitted from the metallic surface. So minimum energy required to escape the electron from the metallic surface is known as the work function. The minimum energy required to make an electron escape from the metal surface is known as the work function. Work function is denoted by phi. Its SI unit is electron volt. In short, that is mentioned by EV. E for electron, V for volt. Work function of a metal is depends on two factors. One is types of metal and also the surface. Which type of the surface is given? Whatever the area of the surface. After that, what is the unit of energy in atomic and nuclear physics? Define it. Here we discuss about that the unit of the work function is electron volt. Actually, that is the energy. Electron volt is the unit of energy in atomic and nuclear physics. Right? What is the definition of 1 electron volt? So when the one electron is accelerated by the potential difference of 1 volt, the energy acquired by the electron is known as the 1 electron volt. For that purpose, here just we try to understand. Suppose there is the conductor. Yes, we apply the 1 volt DC supply across this conductor. There is the 1 volt. So in chapter 3 we discuss about that as we apply the battery across the conductor. So only the electrons are traveling while the positive ions fixed at their lattice point, and we define the electric current. Right? So here there is the positive, there is the negative terminal of a battery are connected at these two ends of a metal. So due to this positive end of a battery, so electrons are attracted by this terminal. So due to the external electric force acting on this electron by the external supply, by the external applied voltage, so motion or the velocity of the electron is increases, therefore the motion of the electron is accelerated motion. Therefore, when one electron is accelerated under the potential difference of 1 volt, the energy acquired by the electron is known as the 1 electron volt energy. That means the change in energy of an electron due to the applied 1 volt battery. So this change in energy is known as the 1 electron volt. So keep in mind this definition, frequently asked in practical exam. What is the 1 electron volt? When 1 electron is accelerated under the potential difference of the 1 volt, the energy required or acquired by an electron is known as the 1 electron volt. The relation between the electron volt and joule is 1 electron volt is equal to 1.602 into 10 is to minus 19 joule. So keep in mind this relation, frequently we are using in numerical. Sometimes in board exam, this relation is not given. The kinetic energy of the electron is given the 300 electron volt. So at that time it is required to convert in joule. So at that time this relation is useful. So 1 electron volt is equal to 1.6 into 10 is to minus 19 joule in short, or Accurate value is 1.602 into 10 is to minus 19 joule. And 1 joule is equal to, take this portion divided by 1 divided by this value, so 6.242 into 10 is to 18 joule. So there is a mutual conversion between the electron volt and joule and electron volt. 1 electron volt is equal to 1.602 into 10 is to minus 19 joule, and 1 joule is equal to 6.242 into 10 is to 18 electron volt. Clear this? So there is the electron volt. Okay. Now last, what is the photoelectric effect? Just we discussed about that when the light or the radiation of the sufficient high frequency incident on a clean metal surface. Like the electrons are emitted from a metal. So that is known as the photoelectric effect. Again, in a clean metallic surface, the radiation or the light is incident on it with the sufficient frequency F0 or the F. At that time, the electron becomes the prey from the metal. Electron are emitted. So this phenomena is known as the photoelectric effect. And what are the electrons emitted are known as the photoelectrons. Photoelectrons. And this method is known as photoelectric effect. Photoelectric. Name is the photoelectric effect. Photo, that means the light. When the light is incident on a metallic surface, in this situation, the electrons are emitted from the metal. So this phenomena is known as the photoelectric effect. Clear this?